Good evening, everyone. My name is Sarah, and I'd like to welcome you back to another Tech Talk in our series sponsored by Seismic. Today, we have the pleasure of welcoming Mickael Contreras to give us a brief talk about end-to-end testing with Cypress. So without any further ado, I will pass it on over to you, Mickael.
Hi, my name is Michael, and I would like to start off by thanking Seismic for this Tech Talk, for sponsoring this Tech Talk. So my Tech Talk will be on Cypress, a modern solution for reliable front-end testing. So we have a couple objectives for today. We're going to learn how Cypress uses Mocha's describe and it syntax and the global Sci object. We're going to get familiar with action commands like click, type, and check, and understand how Cypress uses built-in assertions like should to validate behavior with automatic waiting and retries. Thirdly, we're going to understand how Cypress's asynchronous commands are queued and explore how Cypress fits into the CI/CD pipeline and debugging flows with a focus on stability and performance. So before we get too deep on Cypress, I want to take a step back. So before Cypress, there was Selenium, the industry standard for end-to-end testing, for end-to-end testing framework at the time. It worked across browsers and languages, but it had its trade-offs. Selenium ran outside of the browser, so simulating real user behavior accurately was always a bit of a guessing game. Debugging was rough. You didn't have a visual runner, so figuring out what went wrong meant digging through logs or stack traces. Since it ran in a separate process, you couldn't actually see what the app looked like when a test failed. And most failures came down to a timing issue. Elements weren't ready, pages weren't downloading, and so you spend more time tweaking weights than writing new tests. Cypress came along. Cypress was open source, built on Mocha, and came with its own test runner that ran inside the browser and injects test code directly into the same run loop as your app. Now, Selenium still shines in certain areas like multi-user scenarios, parallelized grid testing, and legacy browser support. But Cypress carved its own lane. It's made for single user end-to-end flows, component testing, and mocking APIs, all in the modern browser. It's focused on speed, developer experience, and reducing test flakiness. It wasn't just another tool. It was a shift in mindset. Cypress brought modularity from Mocha and combined it with deep access to the real DOM right from inside the browser. It felt native, and more importantly, it made testing enjoyable again. So before and then with Cypress. So here's a quick visual just to show what we just talked about. Before Cypress, end-to-end testing meant stitching together multiple libraries, a test runner like Mocha, an assertion library like Chai, something like Selenium to drive the browser, and maybe extra tools for mocking and stubbing. It worked, but it was a lot of glue together. When something broke, figuring out where was half the battle. Cypress came in and wrapped all of that into one framework in a neat little package. It's a test runner, an assertion library, a mock/stub engine, and a browser driver all in one. And you don't need to install extra tools or visuals or configure a bunch of dependencies. You write your test and run it, and you get a visual interface, real-time debugging, and a full browser context right out of the box. So what did Cypress solve? Now that we understand the world that Cypress entered into, let's talk about why Cypress is such a dominant choice in today's industry. So why is Cypress still go-to-go for many teams? Because it solved a fundamental question. How can we trust that our application works in the actual way a user interacts with? Not just in isolation, not just a unit test, but when someone clicks around, submits a form, logs in, or navigates to another page. Cypress gives us that confidence by actually running in the browser. It sees what the user sees, it clicks what they click, it types what they type. It comes with automatic waiting, time travel debugging, and built-in assertions. Even in complex UIs, when timing issues or async flows would usually break other tools, Cypress stayed reliable. Whether you're working locally or pushing to CI, it gives you consistent feedback you can trust. So now, before we can get too deep into this, we need to talk about the test structure. So now we need to talk about the building blocks for Cypress. This structure might look familiar if you used Mocha before. That's because Cypress uses Mocha under the hood to organize tests with global functions like describe and it. The describe block defines a test suite. You can imagine describe as a folder. It describes and groups related tests together. And the it function defines the individual test cases. Similar to how a describe works, it takes in as its first parameter a string, providing a description, and a function called second parameter. Cypress then wraps the test structure inside a GUI powered by Electron, by Electron app by default. To run your test in isolated browser environments, but it also lets you run in the real browser like Chrome, Firefox, if you want to test something closer to production. So while you're writing JavaScript tests, Cypress is combining the structure of Mocha with the power of a headless or interactive browser using Electron. That's what gives you that real user simulation and deep DOM access. So now talking about how do we actually write our test. Think of um, side.get like a smarter version of document.query selector, but with automatic retries built in. So if the element isn't quite there yet, Cypress will wait for it before moving on. You can pretty much use any CSS selector here, attribute selectors, class names, IDs, or data test IDs if your team uses those. In this login example, we're visiting the login page and selecting the email input. Now, just to clarify, Cypress commands don't chain like regular JavaScript methods. If you want to reuse or interact with a specific element later, you can either alias it using the as method and refer to it with the at character, like you see here, saving the email input as at email input, so we don't have to run another side.get again, keeping things clean. Or you can use a .then to access the element directly and do something custom with it later. Here we're using .then to grab the input and manually set its value using jQuery's .value method, which can be helpful if you need low-level control or you want to log something in between tests. Cypress queues these commands in order, but values don't pass down the chain unless you explicitly handle them with .then, as you can see here. All right, so now we're combining two really important pieces, interacting with the app, making sure things work like we expect. Cypress makes it super easy to simulate user behavior with commands like type and check. You just grab the input or button with side.get and call that action directly. Since Cypress runs in the browser, you can literally watch the test interact with your app in real time. In this login example, we visit the login page, type into the email and password fields, and click the submit button. After that, we validate the results using assertions. We check that the URL includes a dashboard endpoint and we use side.contains to find that welcome message and assert that it's visible. Cypress uses should to run those checks, whether you're checking if something is visible, if text matches, or if you're on the right page. .should helps confirm your app did what it was supposed to do. And one of the best parts, Cypress automatically waits and retries these checks under the hood. So even if the DOM takes a second to update, your test won't fail immediately, which helps cut down flaky test behavior. Now, just to understand the Sci object, everything in Cypress starts with the Sci object. You use it to do everything. Visiting a page, getting elements, typing, clicking, making assertions, all of it. What's cool about the Sci object is that it doesn't run these commands immediately. Instead, it queues them up. And then Cypress runs them one at a time in order as they appear. That's how Cypress handles asynchronous code behind the scenes and why your tests stay reliable even when there's a lot going on in the UI. So whether you're using sci.get or sci.type or sci.should, you're really just stacking instructions that Cypress will handle for you reliably and in order. This is just a quick plugin to a quick custom plugin for Cypress that helps visualize this command queue in action. Cool, just quickly moving on into real world testing. This is where Cypress really shines, testing full user flows in one shot. Here we're simulating a sign up process, typing into form inputs, clicking submit, intercepting the API request with sci.intercept, and waiting for that mock response. Once the response comes back, Cypress checks if we're redirected to the dashboard, confirms the UI updates with a welcome message. This isn't just a unit test or a mock component. It's an end-to-end flow that mirrors how the user will interact with the app. That's what makes Cypress feel more real than most other tools. Now, one of the biggest benefits of Cypress is how easily it plugs into your CI/CD pipeline. In most setups, Cypress runs in GitHub Actions, Circle CI, or whatever CI you're using. A PR is open, Cypress kicks off the test suite, and you get notified if anything breaks or your coverage drops every time a pull request is opened or updated. In this example, we have a quick YML file that shows the GitHub Actions workflow that runs Cypress every time code is pushed. But you can also level this up using Docker, especially in your team, especially in a team environment that need a consistent and reproducible setup. We can create custom Docker images with Cypress and specific browser versions. That way you're testing the exact environment your user will see. We can use cross-browser testing with Docker Compose, spinning up parallel Cypress containers for Chrome, Firefox, and Edge, all in your CI pipeline with automations with GitHub Actions. These approaches make Cypress even more powerful in CI/CD workflows, giving you a fast, stable, and realistic testing across environments. Now, this is the main the main magnum opus of Cypress, debugging with the DOM access. Unlike tools that run outside of the browser, Cypress is embedded inside the same browser as your app, which means you have full access to the DOM, local storage, network request, and everything else the real user would see. You can open up the Chrome DevTools, write a test while a test is running, and debug just like you would any regular JavaScript code. And the Cypress test runner gives you time travel debugging. It saves snapshots of the DOM at every step of the test. You can click on any command in the Cypress UI and instantly see what the page looked like at that exact same moment. This kind of visualization feedback is what makes Cypress so powerful. You're not just guessing or digging through logs. You're literally watching your test step through your app. Covering some flaky tests. So Cypress is great at handling async behavior. It automatically waits for elements to appear and retries the commands until things are ready. But it's not magic. You can still end up with flaky tests if your selectors are inconsistent or your app has race conditions. For example, if you're selecting a button with a vague class that sometimes changes or clicking something before the DOM is fully updated, those tests might fail randomly. One of the best ways to avoid this is by using the data all attribute, like data-test ID equals submit button, which are consistent and not tied to styles or layouts. And a big one, try to avoid using side.wait with hard-coded wait times. It might fix your test today, but it'll break tomorrow when your app gets a little slower or a little faster. Trust Cypress retry logic and wait for elements or requests based on behavior, not time. We can't talk about best practices without including the page object model. So instead of repeating selectors in every test, we move them into a class that represents the page. Here. Now that test just calls a method like visit, find email, and submit. It's cleaner, it's easier to read, and if something changes like a selector, we only need to update it in one place. This diagram helps illustrate how Cypress fits into that diagram layer of testing strategy. From unit test at the bottom to full end-to-end test at the top. Unit tests are fast and cheap, but they don't tell you much about how how your actual UI behaves. They're great for individual functions or components. Component tests strike a nice balance. You test the logic like the rendering of an isolated component, like a form or model, without needing to spin up the entire app. Then there's end-to-end tests, which are the slowest and most expensive, but they give you the highest confidence that your app works the way a user expects it to. Cypress allows you to cover all three layers, and while it's known for its end-to-end tests, it's become more popular for component testing too, especially with React. The takeaway here is you want a mix. Don't just write a ton of end-to-end tests, use them where it matters, like flows that involve real user behavior. Fill in the rest with faster, more granular tests to keep your suite maintainable and fast. Under the hood, Cypress doesn't run your commands immediately like a regular JavaScript object. Just really want to hit that home. So every sci call, whether it's sci.get, sci.click, or sci.should, gets added to the command queue. Cypress then processes this queue step by step, making sure each element is presented and ready before moving on. It waits for things like the DOM to be fully rendered, animations to finish, or network requests to complete, all without you having to write set timeouts or manual waits. Everything runs serially, which is what makes your tests consistent and stable. But this is also why Cypress isn't blazing fast for huge test suites. You're trading a little performance for a lot of reliability. And honestly, that's a fair trade-off when the goal is catching bugs before they hit users. Now we'll talk about the asynchronicity. This is probably the biggest aha moment while learning Cypress. It looks like a promise, but it's not quite the same. Cypress commands like sci.get don't return values the way you might expect. You can't just assign them a variable and use them later. Instead, they yield a value when Cypress is ready. And once these commands have run and passed. So if you want to work with the actual DOM elements Cypress found, you have to use .then. Cypress will wait for the element to exist, retry if needed, and only then will it pass that element into your .then callback. This pattern is part of what makes Cypress so powerful. It keeps your test stable without you manually managing async flows. But it's also one of the things that trips people up the most. So, rule of thumb, never assign Cypress command results to variables. Always use .then when you need to access the value. So to wrap things up, Cypress isn't just another testing tool. It gives us the confidence that our app works the way our users interact. It's easy setup, tests read like natural user flows, and it doesn't matter if you're writing a test locally or running it to a CI pipeline. Cypress supports the whole lifecycle, so you can catch issues early and move fast without breaking stuff. The biggest takeaway though, embrace the async model. Don't fight it. Cypress handles a lot of the heavy lifting around timing and waiting. And once you get the hang of it, it's a piece of cake. And here's some of my works cited. And lastly, thank you to Seismic for sponsoring this tech talk. And happy testing.
Wow, Michael, thank you so much for that incredible and wonderfully informative talk. I'm sad to say we don't have time for questions this evening, but I want to thank everyone for coming out tonight, and we will see you at the next one.